All right, welcome back to Zero Tolerance for the 5th episode of Learn to Burn. Today we're going to cover some machines, some cutters, and basically the stages of what I was looking for when I got started compared to where I am today and where we're going in the future. When I first started cutting electrodes, I was using a Fidel machine that you have here behind me. It's a great tool to have in the shop. The parts are easy to get. And when I was beginning, it was the first machine I bought was a Fidel. Easy to work on. A lot of people knew how to run it, and a lot of people knew how to repair it. So there was a lot of help online. You could Google most everything and figure out how to fix it. In my case, I spent 3 months repairing the first one I bought, so I learned a lot about it. But since then, I've learned how to make them as good as they can be. And for what it costs to own one, they're very useful to have in the shop. And for cutting electrodes, absolutely it works. You may not be able to go as fast as you'd like to. As we work today, I can't do them in the Fidel just because of the speed of the machine. Today we have a machine that has a 8-station setup in it, which I've showed in a previous episode. But this machine can machine a lot faster. It's a lighter weight machine than a Fidel is, and it's a 30 taper versus a 40 taper, which allows for higher RPM, faster movements. It's a smaller moving mass, so it works good for me for cutting electrodes today. I am looking to go to a better machine in the future, where we're trying to hit a lot higher tolerances. We can hit tolerances right now in this machine, you know, plus or minus 4/10, 3/10. Some of the medical work we've done, we need to cut stuff even closer than that. So depends on where you're at in the process, and what kind of work you do will determine what kind of machine you need. So it's a hard thing to say you should always have this machine or you should always have that machine. For me, I've grown into them, so I haven't had a lot of options to say I got to have the best thing to start off. That's just not how it worked. I got what I could get, and I made it work the best I could, and I made it go from there. So now I like to buy a little better cutters. We can talk about. I'm going to cover a couple different things: the carbide cutters, the coated cutters, the diamond coating cutters. All right, the next thing we're going to talk about is the sinker EDMs. So once we make our electrodes, we go into the sinker EDMs. Now I've run an old Excello machine with hydraulics, vice grips on the knobs, all kinds of broken things to make them work, and that's what I learned on. I then learned a Charmy machine, a manual EDM, and then we got into sinker EDM with 3D orbiting. And then I learned the Mitz EDM sinker, and now I've also learned the Eagle, the Ingersoll 800 here. As we're burning this, I want to show you what we're looking at. The block in the machine is exactly what I have here. It's actually a 16 cavity mold. You can see they're labeled. This side we did all the trees, and this side I still have to do. This particular program on the EDM will take about 28 hours to burn these undercuts into this side. So I've got 64 locations to do, and this is 16 of those 64 locations. Okay, the Mitz, it really excels at burning cavities and cores and details like that. Kind of a larger, I would say a larger group of electrodes at a time. The Eagle, follow me, we're going to go back over to the Eagle, which is running the Christmas trees. The Eagle and the Charmy that we used to have, we actually sold it so that we could upgrade to this machine, but I liked both machines. I like all three of them. I like the strengths that they all have, and having them gives us the ability to do the specialty work that each machine seems to shine on. So subgates and burning stuff fast, we can basically cover every aspect of that. Okay, now we're at our wire EDM machine. It's a Mitsubishi wire. We previously had a Charmy. It was an older Charmy in the 90s, and the reason we upgraded to this machine is this one is submerged, and it also has a threading option, a self-threading option. Our old Charmy did not, and that's like the main reason that we changed. Also because it was older and it was needing a lot of maintenance, so there was it was time to either put a lot of money into it or make an upgrade. And so we decided to get a larger capacity and a newer machine. So that was the other part of having machines, is we got to look at what we're after and where we're at in the process. We're looking for quality. Always look for quality first. That's what I look for. But sometimes the budget doesn't allow it. So I bought machines that I could afford, that I knew I could make good products with, and that's how I got started. Then I was able to, as I progressed over the years, getting more work and more business, is the quality is what we were known for. So now I can buy machines that have a higher quality, that give us an easier path to getting high tolerances without having to do a lot of manual work. This is a 4-cavity mold for a gun follower magazine, and we're actually wiring out the ejector pin holes because some of the holes are very small and they're real deep, so it's real difficult to drill the holes that deep and have them come out good, because these blocks have been heat treated, and typically when you go through heat treat, the block will move or the holes won't be the right size. So it's better to harden the block and then fast hole and wire these holes right on size, and then matches the pin, and we don't have any flash. All right, you can see these are all the hole locations that we're putting into this block, and what it's doing is it's pocketing them out. It's not leaving a slug in the middle, which is a great feature, which our Charmy didn't have. The old one, the new ones do also, but this is a great option because it can run all night for 5-6 hours and get all these holes done, and they'll be right on size within a couple of tenths for our ejector pins, and it's a huge time saver for us. To conclude the machine part of this video, I would like to talk about quality, cost, your serviceability, your capacity, and your capability of the machines. Having good service is key. For instance, we use a company that, let's say your machines are out of warranty. We look for places that can respond to us when we are in the need to get something done and a machine goes down. We rely on a company called Merrifield Machinery and Service. They've been great. But there's also other companies, but I recommend finding a good company that can help you when machines are not in warranty anymore. And then also when you're buying a machine, the cost is a big thing, especially when you're getting started, but having the reputation of the company that you're buying a machine from, that they have good service and that they follow through, they get you running when you need to be. I have bought machines where that's an issue. So I bought it for price, and at the time that's what I had to do because the budget was limited. So I went ahead and got the machine. It did work out. I was able to get it repaired, but it ends up being something that you're relying on. And then when the time comes and you can't get it fixed fast enough, then you realize that little bit of price in the beginning may have been the biggest difference between getting a job done for your customers or not. Here's an example of a part that we did a repair for. This part obviously had a crash in the mold. It's one of those Christmas tree style plugs or inserts. We had to make some spares, but this is what it's supposed to look like. And this was actually done with a pretty cool combination of machines. We used the wire machine to make a carbide cutter, and then we used the carbide cutter to cut our electrodes to give us the detail we needed. This is that Christmas tree style cutter that we used to make those trees, those Christmas trees. It's actually, here's the electrode. And this was done on the wire machine, cutting carbide with a zinc coated brass wire. And we'll get a good picture of it zoomed up. It's very small. The very tip of it, I guess the width, the narrow width on the end is roughly 16 thousandths thick. It's got a 10-degree backdraft, and that's actually what we used to make that electrode. All right, this part of the video I want to talk about carbon, different grades, and then also copper. We do not cut copper here just because it's expensive, it takes longer to cut, and it takes longer to burn. You can get much finer finishes, but for most of the time we can get away with making a couple extra of carbon electrodes to get the finishes we're after if it's very, very tiny details. I'm going to zoom in on this recipe plate here. For what we typically have used and use most of the time. The most used graphite we use is like a Poco 200 grade, or US 800 is what we use, and we use Belmont to get our carbon from. There is other places that offer carbon in Poco 200. So what I want to talk about is like a low grade carbon, which would be like a Poco 100 is the low grade. You need to make a lot more of them, and you can't get as fine as detail in with the 100. The 200 is a very good general all around for us. It can get all the details that we're after, and it's cost effective, and it cuts well and quickly. There's also copper impregnated graphite, like a Poco C3, which you can see the color difference. And this is a thread electrode, which is an orbiting thread electrode. You can see the difference in the color. It actually has copper in it, especially if you need to do super fine detail and you don't want to use straight copper. This is a great way to do it. It's a little more expensive, but it is worth doing. Poco 3 does not have copper in it. It's very dense, and you can still get fine detail. If you have to do larger electrodes, you don't want to spend a lot of money on the copper impregnated carbon. All right, we're at the wire machine, so I want to cover the difference in wire from my perspective. There is tons of different wires. You typically have a brass wire, which is standard. It's typically what the machine's calibrated to, and then you can get upgraded wires with a coating on them. Usually there's a zinc coating, or there's also stratified wire that you can get with what we use the Charmy machine. That's what we got for that machine, and it was more expensive, but it burned faster. So there's a trade-off based on what you're looking to do, and also there's lots of different diameters. So what we do is we try to have the diameter of wire, which is 10 thousandths for us, that pretty much covers 99% of the work that we do. And then I like to get the zinc coated wire, and we get ours from Belmont, and we also get our wire from Mitsubishi or MC Machinery. But it all depends on what we're trying to cut. We get a general purpose faster cutting wire for most of the things we do, and then if we really need to hit some dimensions closer than a tenth or within a tenth or so, then we'll use some of the higher end wire. All right, next I want to cover the cutters. There is carbide. Everybody uses carbide today. High speed steel is what I started off with, cutting steel and even cutting carbon. And if you've used high speed, you know it doesn't last nearly as long as carbide. So most of the stuff that we use today is carbide, and it has some kind of coating. Like this is an uncoated carbide end mill, and I've cut electrodes with it. It doesn't last long, surprisingly. Then there's a hard coating that's mostly for steels and metal, and then we have a diamond coating, the diamond coated cutters that we use to cut our carbon. And there's a couple different versions. There's like 3 different versions of diamond coatings. What I've run into is a lot of people ask, you know, when do you use diamond coated? They're very expensive, and does it make sense? Couldn't I just buy a whole bunch of cheaper cutters? You can do pretty much whatever you want. What we've done is the cutters that we use the most, and we run a lot of roughing like we're cutting right now, I will buy the diamond coated cutters because I know they'll last a long time, and we won't have to change them out. Now when I get into smaller size cutters, I will use something that's called an amorphous vapor coating, and we can kind of see these kind of cutters are what I'm talking about. They're little, they got a lot of reach, and it's really difficult to see when they wear. Even if you have the real diamond coating, PCD, which is polycrystalline diamond, there's many different versions that they can actually grow the diamond on the cutters, or they can vapor blast it onto the carbide. So my recommendation is for what you're using, if you're using one cutter a lot, it's worth getting the diamond coated cutters. And we get cutters from Whitten and also through Belmont and Leading Edge. Leading Edge has the most variety of small, long reach cutters like I have here. And they supply a lot of them, and they have them in stock typically. So we buy enough to keep a little inventory. It'd be great to have a million cutters of what you need, but when you're buying expensive diamond coated cutters, you don't want to have a ton on hand. And one does go bad or break, you need to have it. So I'm no expert on the actual diamond coating cutters and their names. If you're looking for more information, I would go to the Leading Edge website, and they have a lot of information as to what coatings do what. There's 8098, there's the 8200 or 2000, and those coatings are more of a vapor blast. They don't last as long as the real diamond coated cutters, but for more information, go to the website and check it out. Okay, this is an example of a carbide insert, like a Millstar style, that we use in the trode machine, and it has a little tip on the end that's actually a diamond coated tip that's brazed on there, and it works great. Especially if you have to do something really long or tall, then this cutter does a great job for that. You can see the cutter, it looks like a Burr style cutter, and we use it for our rougher. It's a 1/2-inch cutter we use, and we used one for about a year before I had to replace it, and I literally roughed everything with it. That's one cutter I do recommend getting. It's amazing. It changed a lot of doing a lot of change out for inserts, and it's kept us moving fast on our trode cutting machine. Thank you for joining us for episode 5 of Learn to Burn. We have covered all kinds of cutters, wires, and machines. There's all kinds of new technology out there. As new things come out, we like to find out about it and give it a try also. We'd like to know what you guys use. What do you find works for cutting your electrodes? And leave it in the comments below. Remember to like and subscribe. Tune in for our next episode of Learn to Burn. All right, welcome back to Learn to Burn. I can't believe it. Start over, stop. Hi, welcome back to Zero Tolerance with, okay. Well, why do I get that wrong every time? Episode, I promised we would talk about machines, cutters, and something else. 5 of Learn to Burn. Come on.